Okay, hello. My name is Sean. I'm a junior here at Iolani School. And so this past year, I've been doing my research on how microplastics affect Vibrio vulnificus populations in the Alawai Canal. So I wanted to first talk about why I've been doing this research. I've been paddling for school since freshman year, and I've been paddling before that as well. So I fell in love with the sport, the team, and eventually even the water that I was paddling on. And but the problem is that like looking into the Alawai for just a bit returns horrific information about how dirty it is and how people can get infected so easily from it. And that's not something I want to hear as someone who's out on the water almost every single day during the paddling season. So that's why this year I wanted to look into why the Alawai is so dirty, what's potentially making it even and what's potentially making it even dirtier and more dangerous than it already is. So now let's talk about the specifics of the Alawai. As Hawaii residents, we know that the Alawai Canal is a dirty place, but it's even dirtier than you could imagine. Researchers did fecal chloroform counts on the water, and it was higher than federal limits, meaning that it was dirtier than even legally allowed. And other researchers found a lot of pathogens in the water, and specifically Vibrio vulnificus, which I'm looking into. And this is Oliver Johnson. One day at the yacht club, he had a drunken fight. He fell off the boat with a bunch of cuts and bruises, and then he died of septic shock a few hours later because he contracted Vibrio vulnificus. So yeah, let's talk about Vibrio vulnificus. This is a pathogenic bacteria that you can contract from either consuming seafood that was undercooked and contaminated among high concentrations of the bacteria, or from open wounds in waters with a high amount of the bacteria. Contracting it can cause necrosis, which is the decaying of tissue as shown in this picture on the right. And it's a pretty important bacteria in the world because it affects a lot of people. Around 80,000 people contract it every year. And it has 18% mortality rate, making it pretty deadly. And the problem is that Vibrio vulnificus has been found all over the Alawai. So let's talk about microplastics and what they are. Microplastics are any plastics that are less than 5 millimeters in diameter. So they can range from a 5 millimeter bead of plastic all the way down to a few micrometers of plastic. And being so small, microplastics are able to travel and get into water bodies very easily. So pretty much every single water body in the world has microplastics because it's so easy for these to travel through wind, rain runoff, sewage dumping, large plastic decaying, etc. Even the lint on our clothes can be considered microplastics after they fall off. And these are able to travel the world easily due to their small size and massive range of human influence. There have even been microplastics found in the icebergs of Antarctica, our lungs, and our blood samples. So why am I talking about microplastics when I was talking about bacteria? Previous research done on microplastics has found that bacteria actually take advantage of plastics and grow on them. Bacteria are able to attach to and form biofilms on plastics, helping each other to grow and multiply. The bacteria latch onto the plastics and each other and form a layer around the surface on the microplastic. This phenomenon was so common among microplastics that it was even given a name, the plastosphere. So with this information, I came up with my research question to give me an answer about my interests. How does the presence of microplastics in the Alawai Canal affect the growth of Vibrio vulnificus? My hypothesis, knowing about the plastosphere and the biofilm formation on microplastics, was that microplastics would increase the rate of growth of Vibrio vulnificus populations. So how did I look into my question? I would first make tea bags, some containing rocks and others plastics. And I made sure that all the rocks and plastics were of similar size, about 3 millimeters in diameter, and similar in texture to make sure that any difference in bacteria growth between the materials would be just due to the material. I would put them into the water at about 7:30 in the morning, and then take them out at about 3:30, 8 hours later. I chose an 8-hour time difference, both because it was convenient since I could do it before and after school, and because research papers I read showed that 8 hours was the peak growth time for Vibrio vulnificus. What I did after I collected back the tea bags was plate different numbers of rocks and plastics onto Vibrio vulnificus selective media, being Chromagar Vibrio and TCBS, all the plates of which I made by myself. And to use the plates, I vortex the rocks and plastics in peptone water to shake off Vibrio vulnificus from the surface, and then dump the liquid into a filter apparatus, which would allow me to plate the bacteria. I use cross-plating because using just one plate may bring out false positives, meaning one plate says that a bacteria is Vibrio vulnificus when it may not be. So in this process, I sampled on Thursdays and then plated onto one type of plate that day. And then on Friday, I would pick the colonies that grew and plate them onto another plate. And on Saturday, I would count how many colonies grew on each pellet on average and compare these values. So what I found was that 2.2 times more bacteria grew on the plastics compared to the rocks on average. Here's a graph of the data. Plastics grew on average 0.22 colonies per pellet, meaning about 1 in 5 plastic pellets grew Vibrio vulnificus, while an average of 0.1 colonies per pellet grew on rocks, meaning about 1 in 10 pellets grew a colony. This difference was very statistically significant with a very small error bars as we can see here, and also with a p-value of way less than 0.05, using a t-test for comparison. And this indicates a statistically significant difference between bacterial growth on rocks and plastics. So to make sure that the difference in bacterial growth on the rocks and plastics was solely due to the material, I try to get rid of as many confounding variables as possible. I checked the Vibrio vulnificus concentrations at both the beginning and the end of sampling, and this graph shows us that they are not significantly different, shown by their overlapping error bars. I also researched to see if salt concentrations in the water would affect Vibrio vulnificus concentrations, and they did. So on each day of sampling, I made sure to check the salt concentrations in the water, since I had read in scientific literature, as in this graph here, that salt concentrations had a massive correlation with Vibrio vulnificus concentrations in the water. I also researched to see if the color of the material affects bacterial growth, but I confirmed that it doesn't. So after all of this, I concluded that the difference in bacterial growth between rocks and plastics had to do with the materials and their structures only. The first conclusion I can make from this is that the aloi is getting more dangerous every day. There are many microplastics in every single water body, as I said earlier, and these microplastics, supported by both scientific research and my research, shows that the microplastics are increasing Vibrio vulnificus populations and other bacteria populations in the water. So this is something we don't want churning in the middle of Waikiki, and this is something I did not want to hear as a paddler on the water. So by the same logic, every single water body in the world is also getting more dangerous every day, since the bacteria forming these biofilms are doing it on every single microplastic, which are in almost every single water body in this world. So this could include swimming pools that our friends and family swim in, and even water reservoirs where we get our drinking water from. So what can we do about this? The first thing we can do is make different choices. Maybe use less plastic resources so that they don't go to the landfills and accidentally get into water, and hopefully they don't decay and make more microplastics. Maybe we can hang our clothes in different places so that the lint falling off of the clothes don't fall into water. Another thing we can do is work to clean up water bodies to reduce the amount of microplastics in the water. I'm part of the Surf Rider Club, as Dr. Chan said, and we do stream cleanups to reduce the amount of plastics in our watershed. And we're also doing a cleanup on April 29th, if anyone would like to scan this later and sign up. So there were a few limitations to my research. First of all, my sample size was pretty small. I didn't have that much time to sample after school and on Saturdays because of sports, extracurriculars, and a lot of hard classes that I'm taking. And another limitation was, as I was talking about cross-plating, using two plates can still bring out false positives because there could be false positives on both plates. So it's only about a 90% accuracy rate using cross-plating. So some words of advice to future research students. This has been one of my most fun classes. I made many new friends, and it's been helpful to me, especially as a junior, since research is very important in your academic career. And I also made a lot of senior friends who could give me a bunch of college advice, so I'm not as nervous for next year. The beginning of the class may be hard with a lot of boring annotations on scientific papers due every other week, but as long as you stick it out and make sure you choose a fun topic, that you're interested in and you'll care about the results of your research, you'll have a good time. So thank you so much, Dr. Borick, for helping me to acquire some research materials initially, the wet lab for being such a great place to conduct research, Dr. Chan and Ms. Kobayashi for teaching me the research process and helped me every step of the way, science fair judges who gave me great feedback on my project, friends and family who let me leave them for many hours after school and on the weekends to work on my projects and supported me through the process. And finally, my sports coaches who let me skip practice to do my work and still put me on Vars 1. And finally, here's my references. Thank you for coming.